Today our topic is singularity functions. We are going to study three singularity functions which are very helpful in our further responses, studying our further responses. Singularity functions are also called switching functions. They are either discontinuous or they are we may say that they are discontinuous derivatives. They are very useful in circuit analysis. We study in this chapter only three singularity functions: unit step functions, unit impulse function, and unit ramp function. We are using these three functions in our further studies in this chapter especially. First one is unit step function. The unit step function is the function which is 0 for negative values of t and 1 for positive values of t. It is shown in this figure. This is called the unit step function. In mathematics, we can write it as u of t is equal to 0 for t less than 0 and 1 for t greater than 0. The unit step function is undefined at t is equal to 0. Why? Because it would change abruptly at 0. At this point, this is the 0 point, it would change abruptly at 1 or any value multiplied by any kind of amplitude. Mostly we say that it is 1, its amplitude is 1. If the abrupt change occurs at t is equal to t naught, we may say that if instead of 0, we may say that abrupt change will occur at t naught. Then what would happen where t naught is greater than 0? T naught is greater than 0. Instead of t is equal to 0, the unit step function will become at t minus t naught. This is t minus t naught. This is t at 0 and this is t naught. So we may say that u of unit impulse function is represented with u. U of t minus t naught is 0 for t less than t naught. For less than this value it is 0 and 1 for greater than this value, right? It is called as delaying function, delayed function. We may say that it is a delayed function. If the change is at t is equal to t naught at this point, at minus t naught, the unit step function will become u of t plus t naught. It is addition of this t naught, addition of this value. So we may say that u of t plus t naught is 0 for t less than minus t naught and it is 1 for t greater than minus t naught, like this. Meaning that u of t is advanced by t naught. It is an advanced function. Previous was delayed function. We use the step function to represent the abrupt change in the voltage or the current, like the change that occurs in the circuit also. Especially in control system or in circuit analysis, there is an abrupt change in voltage or current. So if we say that it is a voltage, then we may say that V of t is 0 for t less than t naught and V of t is V naught. It is some value V naught for t greater than t naught. Similarly, we can also time shift the values at t minus t naught or at t plus t naught. We may say that if this is the circuit with this kind of switch, we may say that at t less than 0 the switch is open circuit like this, and at t is equal to 0 the switch is closed circuit, or vice versa as per our requirement. You have also solved this kind of switching circuits previously, so I guess you can got this point. Second one is unit impulse function. Unit impulse function is 0 everywhere except at t is equal to 0. Means at t is equal to 0 it has some value up till infinite and all other values are 0 or undefined. So we may say that it is the derivative of unit step function u of t. It is a derivative of u of t. It is 0 for t less than 0. It is undefined at t is equal to 0 and it is 0 for t greater than 0, right? It is, we may say that, derivative of u of t and it is called delta function or unit impulse function. Impulsive current and voltages occurs in circuits many times. I think you have to read these topics in your book for your viva perspective and also for the further studies. We are going to use these three impulse functions in our further lectures, right? So in circuit analysis it is mostly useful. It can be helpful when we got a sudden impulse or sudden switches, or in mathematics. The unit impulse may be regarded as the applied or resulting shock. It may be occurred due to some resulting shock. And most important thing is it is for very short duration, very short impulse. If we integrate it, we got a 1, value of 1. You must know what are the derivative results and what are the integral results of all these three functions. At t is equal to 0 negative, the time just before t is equal to 0, and t plus is the time just after t is equal to 0. For this reason, the customary to write 1 denote the unit area beside the arrow is used to symbolize the unit impulse function. It is symbolized in this diagram. And you may also shift this impulse. If you wanted to shift this impulse to this point, you can say that -4 is its amplitude, -4 function t minus 3. Similarly, if you shift your impulse at this point, you may say that t plus 2, 5 of impulse into t plus 2, right? It is time shifting as you have studied previously in unit step function. Now third one is unit ramp function. You see the direction, it is a ramp. Integrating the unit step function results in unit ramp function. Unit ramp function is 0 for negative values and it has a slope for positive values. This is the slope of our unit ramp function. The unit step function was derivative, no, sorry, unit impulse function was derivative of unit step function, and unit ramp function is integral of unit step function, right? It is 0 for t less than equal to 0, and it is t or slope for t greater than equal to 0. The unit ramp function may be delayed or advanced as we have done previously. If you shift it to t naught, it would be starting from this point. Before this point, all the values are 0. And if you shift it backward at minus t naught, it would get a slope at this value, and before that minus t naught, all the values would be 0. You can shift the. You should keep in mind all these singularity functions, especially impulse, step, and response, because we are going to study these three in our further studies. And you must also know their relationship. You know that the derivative of step function is what? Derivative of unit step function is impulse function. Similarly, the integral of that unit step function is, it is ramp function, and vice versa. If you can do the opposite of that function, if you can integrate it, you got a, if you integrate this function, you got a unit step function, right? You have to memorize all the formulas, especially their relationships. What, which one is the other's derivative, which one is the other's integral. You have to know all the relationships among them. What is the relationship between unit step function and unit impulse function, unit step function and unit ramp function? Similar is the case with other twos, right? This is your assignment for today's lecture. Thank you.